Welcome to AP Calculus BC. Today is day 2, and we're going to be using limit strategies to solve limits. And these strategies are substitution, simplification, and multiplying by the conjugate. So let's get started. So I've already prepared for us 4 limits here. A few of these will be using substitution, and a few of these will be using simplification. And so let's start with the first 2. So A, it says take the limit as x goes to 5 of 7 times the square root of x plus 4. And so in this case, it's actually okay for us to just plug it in. So if we do plug it in, it will be 7 times 5 plus 4. 7 times the square root of 5 plus 4. And so this will just simplify to 7 times the square root of 9. And as we know, that's just 3. And that's just 21. For part B, it says we have to take the limit as x goes to pi of 2x sine of 2x. And so in this case, we can also just plug it in. So I'll just plug in pi for each of these x's. So it just becomes 2 pi sine of 2 pi. I'll put the parentheses just for clarity. And so we just need to evaluate what sine of 2 pi is. And so if you are looking on a unit circle, then you can think of 2 pi as a full rotation back here. And so the angle will look like that. And this ray right here will be back to where it started. And it will be 0, 1. Oops, I lied. It will be 1, 0, And that will just show, since the y-coordinate signifies the sine, this will also just be 0. So sine of 2 pi is 0. And that just results in 0. The next two are a little bit more complicated, part C and D. We have take the limit as x goes to 2 of this rational function. So we have x squared minus x minus 2, and then we have 2x squared minus 7x plus 6. And so if we do try direct substitution, let's just see what happens. So it would be 2 squared minus 2 over 2 times 2 squared minus 7 times 2 plus 6. This top part, that's 4 minus 2, and that's just 0. This bottom part, 2 squared is 4. That would just be 8 minus 14 plus 6, and that's also 0. And so we've reached an indeterminate form. Let me just write that down. Indeterminate form. Basically, what that means is we can't really conclude anything from this. It's because we're dividing by 0 and it's 0 divided by 0. So this is not really helpful to us. So we should try to use a different limit strategy. So we couldn't solve it using substitution, so we might as well try simplifying it. And so let's try to simplify this part right here. And so we can rewrite this as the limit as x goes to 2 of, well, this top part, it's a polynomial, and it looks like it's probably factorable. So let's try factoring it. So if you're thinking of like a reverse FOIL type of situation, then we need some kind of x and x here to make x squared. And then for this 2, we need probably 1 and 2. And to get this negative x, we'll probably need this to be negative and positive, which also works because plus 1 times negative 2 will get you negative 2. And then plus 1 times x, and then negative 2 times x will get you that negative x. So this is a correct FOIL formation. The bottom, we can also probably use FOIL. So let's try that out. So let's do, well, this 2x squared clues me that it's probably going to be 2x into x. And the 6 is probably going to be either 1 and 6 or 2 and 3. So I'll try 2 and 3. So I'll put 2 and 3 here. And in order to get this negative 7x and this positive 6, I'm assuming they probably have to both be negative. So that would be 2x times x squared minus 3x minus 4x, which gives you that negative 7x plus 6. And so this is a valid form of this. We just simplified it. And so the benefit of doing this is we can actually cancel out this x minus 2 term right here. So if we do that, we can actually simplify it. That's why it's called simplification. So this will become the limit as x goes to 2 of x plus 1 over 2x minus 3. And if we plug it in, it will be, what is that, 2 plus 1 over, well, 2 times 2 is 4, minus 3 is 1. So I'll just write it out. So 4, actually, I'll show you the substitution. So it'd be 2 times 2 minus 3. And as we said, that's just 3, and that's just 1. And so we can simplify. Our answer is 3. Part D is probably a little bit more complicated. It says take the limit as x goes to 3 of x squared minus 9 over x cubed minus 27. If we do direct substitution, we can get, what is that, 3 squared minus 9 over, oops, not x, I mean 3 cubed minus 27. And that also gives us an indeterminate form of 0 divided by 0. So that's not helpful to us. And so that kind of clues us. We should probably use a different strategy, and so we should use simplification. So I noticed that this top part, it looks a little familiar, don't you? It looks, actually, I'll just write it here. It looks like it's in the form of a squared minus b squared. And the bottom part looks like it's something like a cubed minus b cubed. And so we actually need to know these formations because this could actually be simplified in this one too. And so this is actually called the difference of squares. Very on the nose. And can you guess what this one is? Yeah, it's the difference of cubes. How exciting. Cubes. And so we can actually rewrite both of these. And so this will actually just become a minus b times a plus b. And if you actually do the FOIL, if you use FOIL, I'll write it here. If you actually do FOIL, you will see that it actually gets you this form. Same thing over here. This will become a minus b. And the way I remember it is you take a, you square it, and then you flip the sign. So do you see how it's a negative here? I'll flip the sign, and I'll put a positive, and then you multiply a and b together. So it would be ab, and then you add b squared. So this is going to be really useful in simplifying this. So let's rewrite the limit. The limit will be, take the limit as x goes to 3, and I'll make a big fraction bar. A little crooked, or whatever. So the top part, well, it's a difference of squares. I'm going to actually think of this 9 as a 3 squared. And so we can rewrite this as x minus 3 into x plus 3. And then if you do FOIL, you'll see where I got that 9. Same thing on the bottom here. This 27, I can think of it as a 3 squared. So I can rewrite this as an x minus 3, and then I'll follow the rule here. So it will be x squared plus, well, if this is x and this is 3, it'll just be 3x. And then plus, our b value is 3 here, and so I'll write 9. And voila! Maybe you've noticed we can get rid of this x minus 3 part, and look at that. We've simplified our limit. So it becomes the limit as x goes to 3 of x plus 3 over x squared plus 3x plus 9. And if you do direct substitution now, we can do 3 plus 3 over 3 squared plus 3 times 3 plus 9. The top part, that will just be 6. 3 plus 3 is 6. The bottom part, 3 squared is 9. 3 times 3 is 9. And that's just 9. So it's 3 9s. So that's 3 times 9, which is 27. And we can actually simplify this. This divided by 3 is 2. And this divided by 3 is 9. So our final answer is 2 9ths. Okay, we're back. Let's try to find the limits by multiplying by the conjugate instead. So this is a new limit strategy that we can use. The first two, we can usually use those for polynomials and simplifying, but when there are roots involved, especially the square root, we're usually advised to multiply by the conjugate. And what this means is if we had a term, let's say a minus b, then we can multiply it by a plus b, and we'll get a squared minus b squared, and vice versa. And this should look familiar to you because this is also the difference of two squares. So we're just working, we're working backwards from what we did last time. And so let's just keep this in mind. And the reason why this is so useful is, let's say we had the square root of m minus n or something like that. And if we multiply by the square root of m plus n, then this will become the square root of m squared minus n squared. And you see how that will simplify? Same thing. We actually can make both of these square roots like that. And that will just become m minus n. And so this is a very useful strategy when there are roots, especially square roots, because we can just cancel them when we square. So let's get started. We're starting with a, and it says take the limit as x goes to 9 of x minus 9 over the square root of x minus 3. And if you do direct substitution, you can see it'll give us like a 0 over 0 result, which is not what we want. And so instead, we're going to multiply. Actually, I don't need the equal sign. We're going to multiply by a form of 1. Because if you did this, this actually doesn't change the answer, or this fraction over here. And so we can rewrite this 1 as the limit as x goes to 9 of x minus 9, and this is kind of troubling, so we can multiply it instead by a form of 1. So we can, instead of the square root of x minus 3, we can multiply the square root of x plus 3. And if we remember up here, this will just simplify our problem. And so if we rewrite this up here as well, then do you see how this is a form of 1? Remember, anything divided by itself will always equal 1. And so this is valid. And so, if we multiply this out, this will become the limit as x goes to 9 of x minus 9 times the square root of x plus 3. And this bottom part, well, the square root of x times the square root of x is x. And then if you do FOIL, the middle parts cancel out, and then negative 3 times 3 is negative 9. Did you notice something? Yeah, we can cancel, my favorite part. We can cancel these out, and now we're just left with the limit as x goes to 9 of the square root of x plus 3. And if we plug in 9, that will be the square root of 9 plus 3, and that's just 6. Let's try part B. B says, what is the limit as x goes to 0 of, what is it? The square root of x plus 2 minus the square root of 2 over x. And so in this case, we're actually trying to simplify the numerator instead of the denominator, like the last problem. And so let's just get straight to it. Let's multiply by a factor of 1. And let's use the conjugate. So instead of this minus, we can rewrite the top part with a plus root 2. And then we can use this fact up here in order to solve. And remember, what you do to the top, you must do to the bottom as well. Like that. And that keeps it equivalent because this is just multiplying by 1, and that's not really changing this here. So now let's simplify. So this will be equal to the limit as x goes to 0. This top part is actually going to massively simplify. Multiplying this will get you x plus 2, and then you subtract this squared, so it will be 2. And then the bottom will be x times whatever this is. So we don't even need to simplify. X plus 2 plus root 2. Now let's simplify the top part. Well, x plus 2 minus 2 is just x. In fact, let me write the limit notation first. The limit as x goes to 0 of just x over x times the square root of x plus 2 plus square root of 2. We can cancel. It's canceling time. This x and this x can cancel. And remember, every time you cancel, make sure it matches the limit. So we can actually cancel this because we're not actually plugging in 0 here. So this will result in the limit as x goes to 0. Remember, it's always 1 times x. And so this will just become 1. The bottom part remains the same. What is that? X plus 2 plus root 2, like that. And if you plug in x equals 0, then it will become 1 over, what is that? Root 2 plus root 2. And that's equal to 1 over 2 root 2. If you want to rationalize this, you can multiply top and bottom. In fact, I'll rationalize it for us. So multiply it by root 2 over root 2. Remember, there's the idea of multiplying by 1 to not change it. 1 times root 2 is root 2. And root 2 root 2 times root 2 is 2 times 2. And that's just root 2 over 4. Okay, let's try part C now. Part C is probably the most challenging out of this. It's going to be, oops, I forgot the limit. Sorry about that. The limit as x goes to 0 of x, the square root of x plus 4 minus the square root of 2x plus 4 over the square root of x plus 9 minus the square root of 2x plus 9. And pause and take a moment to see why substitution would not work in this situation. Okay, anyway, we're probably going to have to use a multiplying by the conjugate in this situation. And so maybe you notice both of them need conjugates, especially since both of them have the square root. In these past situations, only the denominator and the numerator, or the numerator, I mean, had it. And so in this case, we'll have to multiply by 2 conjugates. It's going to be a lot of math, but trust me. So our first one, let's get rid of the numerator first. We want to multiply by x, the square root of x plus 4 plus the square root of 2x plus 4. Make sure you keep your signs the same because you can think of this like square root as a single like object. So it's this minus this times this plus this. And then you got to make it a factor of 1. So as so. And I'll pull out a separate color. We'll have to multiply again by the conjugate of this bottom part. So this will be the square root of x plus 9 plus the square root of 2x plus 9. Same thing on the bottom here. X plus 9 plus the square root of 2x plus 9. And same thing here. If you think of these two as objects, it's going to be this minus this times this plus this. And make sure everything inside is the same. And so now we can simplify, finally. So I would actually recommend to multiply the conjugates first and then apply this last. And then for the bottom one, multiply the conjugates first and then apply this last. So this is equal to the limit as x goes to 0. Remember your limit. The top part, well, this will simplify to, what is it, x plus 4, correct? Minus 2x plus 4. And then I'll put brackets here. Times the leftover. So we had to multiply by a factor of 1, and so we got some extra stuff. So it's going to be x plus 9 plus, square root of x plus 9 plus the square root of 2x plus 9. The bottom part is going to be, we're going to take this part right here and this part right here, and we're going to rewrite it as, what is it, x plus 9 minus 2x plus 9 times the leftovers. So it's going to be this part right here. It's going to be the square root of x plus 4 plus the square root of 2x plus 4. I think that's correct. Okay. Whew, this is a doozy. So we can't really simplify this further, but we can simplify this. So let's see what it gets us. So that would be the limit as x goes to 0 of, well, this top part, x plus 4 minus 2x plus 4, we can rewrite it as x plus 4 minus 2x minus 4. So I'm just distributing the minus signs right here. And the bottom part will be x plus 9, distributing the negative, minus 2x minus 9. And then, wait, let me draw the fraction bar. Multiplied by whatever stuff that's left. So I'll just rewrite it like this. So square root of x plus 9 plus square root of 2x plus 9. Same thing on the bottom, the square root of x plus 4 plus the square root of 2x plus 4. Now we probably should simplify this part. So if you noticed, 4 minus 4 cancels out, 9 minus 9 cancels out, and we're left with x minus 2x, which is negative x, and x minus 2x, which is negative x. So I'll rewrite it here, which is equal to, in fact, let me get my white. Gosh. The limit as x goes to 0 of, this just becomes negative x, and this becomes negative x as well, times all this leftover stuff. And so maybe you've noticed this actually just simplifies to 1. And so I'm going to cross it out, but it just implies that that just becomes 1. And so the limit is actually just this, the limit as x goes to 0 of the square root of x plus 9 plus the square root of 2x plus 9 over the square root of x plus 4 plus the square root of 2x plus 4. And if we do plug it in, it will become, well, all these x's will become 0. So it will become the square root of 9 plus the square root of 9 over the square root of 4 plus the square root of 4. And that's just going to be 3 plus 3 over 2 plus 2. And that's going to be 6 over 4 or 3 over 2. And that's our final answer. I hope you enjoyed this day 2 of using limit strategies to solve limits. Next time, we'll be looking at one-side limits and seeing if limits exist. Thank you for watching.